In this video, we have three examples that we're going to go over with the average rate of change. The first one is a context with a car. We're going to use miles per hour. The second one, we're going to use a graph and look for the average rate of change on that interval visually. And then the third one, we're going to use algebra along with some function notation, figure out that average rate of changes, but we'll also graph it in Desmos and see what that looks like visually. Just because I think there's a lot of value looking in that visual so you kind of see what's going on with all the algebra. So a car starts at 10 a.m., drives a little bit of time, and then at 2 p.m. Checks the odometer and it went a certain distance, right? We want to figure out the car's average rate of change during that time period. So we're going to use the unit miles per hour because that was given to us in the problem. And to calculate the average rate of change, we're going to look for the change in miles and divide it by the change in time, which in this case is hours. So the car started with this number of miles right here, and then it ended its trip with this number of miles. So we're going to do subtraction here. That'll give us the change in miles or change in distance. Then we're going to go ahead and divide that in the change in hours. So a car started at 10 a.m., it traveled to 2 p.m., so we'll go with 2 p.m. and take away the 10 a.m. And this is going to leave us with 224 miles on top, and we're going to divide that by 4 hours. If we reduce it, we'll be left with 54 miles per hour. So that's going to be the average rate of change that car drove. You know, sometimes it's going to be driving faster, sometimes it's driving slower, but on average in that time span, which was in this case, it looks to be 4 hours, it was about 54 miles per hour. In example 2, we want to figure out the average rate of change on the interval -2, 1. And this is referring to the x values, part of the domain. So we want to go from -2, this is where x equals -2, and we're going to take it to where x equals +1. So that's going to be this point right here, that -2, to this point right there where that's +1. So we're going to use the change in y and we're going to divide it by the change in x. So in the numerator, we're going to use change in y first. So let's start with that. So it looks like we started from this point and then we continue down that line a little bit. So all we really care about is that change of y now. So we're going to go down to about here, right? And then it looks like that we're at -4. And you can tell because that was in the point given right there. So we will do -4, and then we want to subtract because we want the change in y where we came from. So if we went down to -4, we're coming from then this value right here, 2. So then we're going to subtract a +2. So we went to -4 and we came from 2, so we want that difference. Now we're going to divide that by the change in x. So we started with -2, right? And then we are going to travel right here and we stop. It looks like we stop at +1. So we ended with 1, so I take 1 and I subtract what we started with, which was that -2. And then we could actually do the math. So -4 minus 2 is going to be -6 over 1 minus -2 will be 3. If we reduce that, that'll be -2 over 1. So the change is going down 2 and then over to the right 1. So we always go down 2 over 1, down 2 over 1, down 2 over 1. But that would be the average rate of change right there, because that's not a perfect straight line, right? We still have a polynomial here, so we're kind of curving a little bit. It looks like a straight line, but it's not. But that's going to be our average rate of change on that interval right there from -2 to 1. In example 3, we're given a function f of x, and we want to figure out the average rate of change on the interval. So we are going to go from 2 and we're going to end up with 7. So we want that average rate of change from 2 to 7, and those are going to be x values. Again, when we're dealing with our intervals, the intervals are always x values. So I'm going to use function notation here to figure this out. I'm going to start with f of b. So we're going to take our function that we started with right here, f of x. I'm going to substitute in my b value. So the b value is going to be my second x value right there. So I'm going to plug that into the function. So there we go. I take my b value, which was 7, and and I plug that into the function every time you see x. So there it is, 7 and 7 right when we saw the x's. Okay, now I'm going to subtract my f of a. So my a value, right, in my formula there is my 2. So then I plug in my a, which is 2, into that function. So there we have it. We have f of b, which was f of 7, and we're going to take away f of a, which is f of 2. We're going to divide that all by our b minus a. So our b was 7, and we're going to take away or subtract our number 2 there, and that was our a value. So our final step is just to simplify all this. So I would break it up into chunks. I'm going to take the blue part right here, and I'm going to throw that into a calculator, and if you do it correctly, we should be left with a negative 124. Whoops. And then I'm going to subtract. I'm going to take everything in green here, put that in the calculator, and then we should be left with a negative 9. Divide that by 7 minus 2 is 5, equals, if we take negative 124 and take away a negative 9, we're left with a negative 115 divided by 5, and then simplify that one more time, and you're left with a negative 23 as the final answer. So the average rate of change on this interval up here from 2 to 7, again, those are x values, and we're going to be changing on average negative 23. Before we wrap things up, I'm going to jump into Desmos real quick and show you the visual of that average rate of change, what it looks like. So I have my function f of x graphed. I'm going to add in x equals 2 as well as x equals 7, because we were looking for the average rate of change on that interval. So those are the x values. And I'm going to change my graph a little bit so it looks better. I can see everything that's going on. So this visual is a little bit better. When we plugged in our 7 for x, we got a value of y that was negative 124. And then when we plugged in 2 and evaluated, we got a negative 9. So there's our points. So those should look familiar. And then again, we are looking for the average rate of change from 2 to 7, which was the interval. So we had an answer of negative 23. That's just the average, because you can see from this point to that point, it's not a line. So it's not going down consistently like negative 23 over to the right one, down negative 23 over to the right one. It's not consistent like that, but that's just going to be the average, because again, we have that curve. It's not going to be a straight constant change. So that is a good visual to be like to show you what's going on. It's hard to see that when you have the algebra there, so hopefully that helps.